Hello. Uh, Today we will discuss a aspect of cloud computing where we will see that if there are a number of providers. So, how do I select, whether there is a way to select the things, and what should be the approach of the things. So, what we see in a present day scenario that there are increasingly availability of number of provider at various level, IS level, PaaS level, SaaS level. So, at various level, and there are several requests from the customer side, right. So, customer has a expectation or requirement per se, and the providers provides a particular things with some SLAs, right. So, first of all the customer wants to know that which provider, how to select a provider out of a bunch of providers available, where the customer's expectation will be satisfied and the SLA will be honored, and the providers also wants to maximize his profit, right. Some of the aspects already we have seen. So, given all these security and other aspects in place, we want to look at that whether in this cloud quote unquote marketplace, how do I whether there is a possibility or approach to look at the things. So, that is exactly we like to look at. So, it is broker for cloud marketplace. So, what we look at, there is a number of providers available, there are several customers. So, it is a marketplace. So, how to select the thing. So, if you look at, if we see that there is a rapid growth on available cloud services, right. So, it is there are several providers, several service providers, right, and there is a rapid growth of the things, like, and huge number of providers with varying quality of services things are there, right. So, different providers have different quality of services and type of things, different type of customer use cases. So, customer based use cases, each with different requirements or with several requirements, customer use cases are there. So, the requirements of the customer is based on the need of the customer, it varies from customer to customer. So, that is another aspects, and from some reference what we see that this number of Amazon's VMs created per day from 2007 to somewhere 2011, it has remarkably changed, right. So, there is a huge demand for the things. So, keeping all those things in the offering or in keeping in this mind, there is a need of a middleman, right. So, there is a need of a middleman, we can call as a agent or broker, or sometimes it may be a intelligent broker to suggest the best cloud provider to the customer or safeguard the interest of the customer, right. So, I require a quote unquote middleman or a intelligent broker broking service which safeguard the definitely safeguard the interest of the customer, and also suggest the best cloud provider or cloud service provider of the customer based on its requirements, right. So, this is a need of the hour, or people are working on it, that how can I select, how can I select a things with a intelligent agent or broker. So, there are definitely motivation that this flexible selection of cloud provider, that is one of the things. Trustworthiness of the provider plays a important role, how much I trust or I can be able to trust a provider is there. How do I calculate the trust is a big challenge. Some of the aspects we have looked into or discussed during the security when we discussed about cloud security. So, trustworthiness is important, right. So, that is one of the factor. Monitoring the service, that whatever the things are there, how services are monitored, and of course, there is a important aspects of vendor lock-in, right. So, whenever there is a vendor, so there is a problem of vendor lock-in. So, that means you work with some provider and you get locked with the provider because of the services, right. Now, if the provider is not giving the service up to the mark, or the provider or the CSP does not provide the service, then going to another vendor is difficult. And it is not only that, now you need to go for a in the terms and condition of the, or the customer has to go for the terms and condition of the provider. So, vendor lock-in is also an important aspects which we need to look into the thing. So, there are several motivations, there may be several other motivations, but end of the day what we look at that I need the mechanisms to or a broker to find the best possible cloud things. So, based on this motivation, if you look at the objectives, one is the selection of most suitable provider, satisfying customers QoS requirements, that is the major objective. Calculation of the degree of SLA satisfaction and trustworthiness of the provider may be one of the sub objective, right, like how I can guarantee that the degree of SLA satisfaction and trustworthiness of the provider, that is other objective. That one is selecting and type of things. Decision making system for dynamic service migration based on the experienced QoS is another aspect, right. So, it is if the provider if I do not get that appropriate service, or that is from the customer point of view, or from the aspects of the that a middleware, that whether I can migrate the service from one provider to another provider, right. Like we look at that VM migration, if there is a any outage on the VM, whether the application will be migrated on the things. This type of things are being supported by various organizations as we look at on the hardware and type of things, like at the VM level, but whether this type of migration on the whole application from the one provider to another provider, that is maybe there. So, once we do a migration or any of these or many of these aspects, we need to take a call, right. So, there should be a decision making process into the things, right. That is one aspect. So, I need to have some sort of a decision making support which allows me to do that. Secondly, another aspect is there that most of the cases things are not very crisply defined, right. The requirement wise, the your performance wise, all these parameters are not very crisply detached. There is lot of fuzziness, especially in giving the details of the customer. So, what we need to do, we need to account for all those aspects also. So, there are different approaches what is tried, few of them are here, but there are different approaches people have tried, like one is that Cloud CMP, a tool that compares cloud providers in order to measure the QoS they offer and helps user to select a cloud. So, there is a tool which compares the cloud providers in order to measure the quality of service they provide. So, based on that, a user or customer can select a cloud. There can be fuzzy selection mechanism, right. So, there can be fuzzy provider selection mechanism. So, there is fuzzy provider selection mechanism. So, that which takes care of the fuzziness, that is also which well suited, because there are a lot of fuzziness into the description. There is a framework with a measure of satisfaction with a provider, for keeping in mind the fuzzy nature of the user requirements, right. So, considering the fuzzy nature of the user requirement. So, measure of satisfaction with a provider, how to calculate that based on this measure the consumer can take a call. Provider selection framework which takes into account the trustworthiness and competence of the provider. So, there is another way of looking at it is that there is a provider selection framework which takes into account the trustworthiness and competence of the provider, right. This trustworthiness and competence of the provider. So, if you look at these different approaches, so this one is there that it attempts to find a suitable provider for the things. Secondly, there are several overlaps between those type of things, right. Overlap in the sense that how they consider the user or the customer requirements or inputs, the overall mechanism of selection and so on and so forth, right. So, if you look at customer QoS parameters, some of the things like if we consider infrastructure as a service, so what we look at that 24/7 availability with 100% requirement, like it's the I get a return what I pay for it, and there are requirements in terms of the bandwidth requirements and other type of things. In case of a software as a service, the uptime requirement may little vary. Again, the response times is critical. Rather, if you look at this, these are the several type of components which are there. So, more QoS parameters can be there, like in terms of things like even we can talk about storages, we can talk about other quality of services like even security, trustworthiness, competence, risk, and so forth, like availability and so forth. So, so that is in case of any cloud provider, we have a set of parameters which the provider provides, or the promised QoS values, right. They based on things that the provider promise different type of different type of QoS values or QoS parameters, like the provider says there is a 99.99% uptime or so much security level, or maybe this much bandwidth available and so forth, and there are based on that we can have different trust on those things. The trust can be overall the provider, or I can even trust on different parameters, like availability things. I say that this based on the experience, this trust on these things, trust on a particular provider is something like 0 to 9 scale I trust it in 0 to 1 scale I trust it in 0.8 value and trust value of 0.8 and so forth, right. So, there are different trust values and they have been kept independent as they pertain to different parameters, right. That the trust value can be kept independent as there can be different type of parameters for looking at the as those trust values, like promise a particular promise 1 can have a trust value 1, promise 2 and trust value 2, and there are different mechanism of trust calculation, several things for trust, competence and type of things. It goes for history of those things and looking at the history and then calculate, and or third party auditor or third party monitoring units which monitors those trust, and there are mechanisms to calculate the trust. So, if we look at a typical marketplace architecture, so there can be several components, right. One is there are set of providers, right, like provider 1, 2, 3, P1, P2, P3, Pk. There are components like the major black box may be the provider selection decider, right. So, the customer comes with a set of requirement and requests the this particular selection box, and it takes the other inputs and decide the things. The other blocks are like maybe there can be monitoring module which are constantly monitoring whether there is a request or not, it is monitoring the providers, right. There can be a migration module. So, this was monitoring module, it says that the QoS experienced by the VMs for different providers, and you put a input to the provider trust calculator, right. And there is other component is a migration module which is a migration deciders. So, based on this provider trust calculation, this goes for a input of the migration decider, and this migration module keep a track that which are the providers are there, what are their loading capacity and type of things, and based on those it goes on a which providers need to be selected. So, it goes for a provider selection, right. So, one side that requirement. So, this selection procedure provider selection procedure is dictated primarily this monitoring of the different QoS parameters and type of things. So, this may be one such approaches, but there are a lot of nitty-gritty into the things like customer requirement, how it will be taken, whether it is a very clearly defined or there are fuzziness of the things. If there is a fuzziness, how to handle this fuzziness or how to account for this fuzziness. So, there can be fuzzy inference engine which can be deployed out here. This particular things which we are discussing is two of my students worked for their projects, one for BTech and one for MTech projects, on working on an intelligent broker for cloud marketplace using a fuzzy approach, using a fuzzy inference engine. So, there are a major block diagram of this architecture. So, provider selection, if you look at selection of the provider is done using a fuzzy inference engine, right. So, there can be other approaches, but in this case what we did a fuzzy inference engine. So, input is the QoS offered by a provider and it starts worthiness, right. So, it takes the input as a QoS offered by the provider and its trustworthiness. Output is suitability of the provider for the customer, right. So, I have that one side that providers competence, so to say, that quality of services offered by things and its trustworthiness. Other side what we have this customers or the users requirement, right. So, and this fuzzy inference engine in this case takes care of consider these two and finally give a output that which should be the best provider for this particular customer. So, that is that is the goal of the finding a suitable provider in a cloud marketplace, right. Customer request is dispatched to provide with maximum suitability. Membership function are built using user requirement. So, the membership function on the providers on the customer side can based on user requirement that can be built on the fly and then put into the system. So, there not only that, there will be a set of rule set on the customer side that need to be accounted for also. So, from the customer requirement input membership function for the fuzzy system and there is a rule list and there is a output membership function based on those things, right. Whereas, there is providers offerings like what the provider can offer, fuzzification of those things, there is a rule evaluation based on the customer rule list and defuzzification and providers fitness to the customer requirement, that is other aspects of the thing, right. So, this whole thing lead to provider selection. So, this basically fits into the system and it gives a provider selection. So, like a typical scenario where for this experimentation that provider selection input membership function with different things like extremely poor, very poor, medium, good, very good, excellent and this type of different states and using this input fuzzy membership function. So, what we do that is based on the QoS and based on this that what is the input variable is the means with input as trust that having that membership function again at different scale, then we construct that output membership function, the output membership function with those levels of extremely poor, very poor, poor, medium, good, very good and excellent. Based on this we calculate that what should be the suitable provider for the things. There is a monitoring module which monitors the overall processes. So, it takes different available experience values, that is availability experience by the particular VM, bandwidth experience by a particular VM or a particular time, then what are the different promise for different VMs by a particular provider, and so on and so forth, and generate that SLA satisfaction of a particular VM I on availability, SLA satisfaction of a particular VM I on bandwidth, and so on things. So, performance of this sort of service provider or service instances for a particular service instance I in the current monitoring period is generated. So, that means what we try to do this, there we are trying to monitor vis-a-vis their performances of different providers and based on different service instances, like or SIs, like that how they are performing. This is important for selecting a particular provider. So, what we are doing, if you look at the big story, so we have on side the customer, it has some requirement, I need to fit this requirement to some provider or a set of provider and suggest the customer that see this is the provider is there. For the provider end, there is a continuous monitoring of the thing, right, that with even with performance histories, right. So, what are the different performance, what is the promise value and what is the experienced value, right. One is the promise what the cloud provider gives and what the experience and the based on this promise like availability, bandwidth, how much is experienced by the user or the customer with at different point of time. So, while calculating at time t, I consider for different provider this monitoring unit gives that for different service instances how is the performance of this of a particular provider or a particular provider I. Based on that and taking the suitability of the customer, the system set say that this is the possible provider, or it can even rank that this is the first one, second one, and so on and so forth. There will be a different other factors, like here maybe we are considering availability and bandwidth, there can be other different other factors, even cost is a factor and requirement plays a big role, that whether mine is a time critical or say data critical, or more accuracy is more important or the time is more important, and type of things come into play. So, if there is something running on a particular system provider, then if there is a need of migration from one provider to another, so there is a need to have a thing called fuzzy, there is a another decider block is needed for migrating for the migration decision, right. So, it it uses the fuzzy inference engine, there can be different input F1, F2, F3, F3 for different providers and output will be the degree of SLA satisfaction for a service instance I, right. If the degree of SLA satisfaction is less than threshold is then migrate. So, what we are doing, I am my particular from the customer's particular service instance is running. So, and degree of satisfaction is being calculated. If the degree of satisfaction is less than the threshold, there is a need to migrate to a new provider or a new service instance, right. Here also this it is done through fuzzy inference engine, and this is a typical instance of a output member sim function with different levels. We shows that the degree of SLA satisfaction, based on that it is decided that whether the migration is needed or migration is need to be executed for a particular service instance. So, the selection of the target provider is somewhat similar to this provider selection procedure, which is being monitored and so on and so forth. Selection done using a fuzzy inference engine in this case also. So, what we have here is that it is true for any type of service provider, though primarily it is more pertinent for IS type of marketplace, where this infrastructure as a service is being provided, but it is true for any type of cloud, right. So, here we did some case study just to show that whether how much effective it was, whether it makes sense to fuzzify the or using this fuzzy approach. So, we did a simulation with 10 providers with varying offered QoS. 500 requests for VM are considered. There is a done through a year long simulation, that means over a year the time period has been taken as a year, taking on a daily basis. Few provider exhibit performance degradation. So, degraded QoS parameter follow a Gaussian distribution. So, if there is some sort of a degraded QoS has been done using a Gaussian distribution, and comparison made with conventional minimum cost CRISP broker. So, that means there is no this sort of fuzzy system. If there is a CRISP broker, that means it takes a call yes or no type of things, then with minimal cost on those decision making, and then how it performs compared to that. Like one is showed that the average availability, this blue color is the user requirement, green is the for the CRISP broker, and red is the fuzzy. So, what we see that it may not be always following that user requirement, but in a sense it is better than the CRISP approach. Similarly, this is for average bandwidth. Again, here blue is the user requirement, red is the fuzzy, and green is the CRISP broker. So, here also we can see that it is better than the CRISP broking type of thing. Similarly, average cost per VM per hour, if we look at the same way that over a scale the fuzzy gives a better result. So, similarly, though it is predominantly for SaaS IS type of provider, but we did some experimentation on the SaaS or some simulation on the SaaS marketplace. So, here also some sort of 10 providers are considered with 500 service requests, again simulated over 365 days. Few provider exhibit performance degradation, QoS parameter follow a Gaussian means QoS degradation has degraded QoS follow a Gaussian thing, and comparison with the conventional CRISP thing. Here also what we see that the dotted line is the user requirement, red is the fuzzy, and CRISP is the green. So, over again a range, the fuzzy seems to be following better. That may not be always the case, but it is likely to be better. It is likely to be mapping the user requirement in a better way, that fuzzy inference engine. Similarly, this is on the average response time over again the particular period of here in this case 30 days, and that how the overall performance is there with fuzzy CRISP and with respect to user requirement. Similarly, this is the average cost of a particular instance of the things, right. So, what we see that we basically implement this sort of a fuzzy inference engine in order to map this user requirement to the rather match the user requirement with the provider's offerings, and try to fit the best provider with the user with the particular user requirement, or set for a particular user of the for a particular service instances. And what we like to look at, there are several future scope, especially in the research fund for this particular work. There is a specification of flexibility in the user QoS requirement is there, right. That is whether we can make it flexible of QoS requirement. Comparison again existing approaches on production workload, right. So, that on a live workload whether we can compare several classes of customers. Now, there can be you see their customers can be categorized into different classes of customers, right. It is instead of taking individual customer or user, I say that this user is this category of customer, this user is this category of customer, and so and so forth. And it all and also depends on the type of applications, type of services it is looking for in those type of things, and extending the things for any type of services or XaaS type of services may be important aspects of the things. Nevertheless, this type of finding appropriate match in a cloud marketplace is gaining a lot of interest both from the real life point of view or commercial point of view, and from the research point of view, how to find a suitable things, how to measure or how to say it formally that what has been selected suitable is the best possible things, right. If not the best, but it is something near based with some sort of a guaranteed type of services. So, this is again those who are interested in future study research. So, this is a important aspects of because it involves lot of aspects, right. One is that how to monitor them, how to calculate trust, competence, and SLA guarantees or SLA violations, or how SLAs has been satisfied over time, and based on that at a present time T, how to project that what are the things are there. So, it plays an important role in modern day cloud infrastructure, or making cloud computing more popular across the things. So, with this discussion we stop today, and we'll be continuing with some of these aspects of cloud computing from different perspective in our future lectures. Thank you.